Jai Hind students, so this is the first lecture in our complex lecture series and the topic is tabulation method from unit 1. So what is tabulation method? So before tabulation method we have been using K-maps for minimizing Boolean expressions. One option is to use Boolean laws which we found to be quite tedious. So we switched to Carnot maps or K-maps, but K-map has also a limitation that it can be used till 5 or 6 variables. So beyond those 6 variables, it becomes quite tough to use K-map as the grouping possibilities and the grouping patterns becomes very much different, very much diverse. So to avoid that, there is a different method which is known as tabulation method, and it was given by the scientist named Quine-McCluskey. So it is also known as QM method or Quine-McCluskey method. So why it is known as tabular method? Because the Boolean expression is minimized by preparing a series of tables. That's why one after another multiple tables are being formed. So that's why it is known as tabular method. So let's start. So the key requirement for solving a Boolean expression or any Boolean expression with min terms or don't care is that we should be available with the min terms. Okay. So if min terms are not available to us, first step will be to obtain the min terms from the expression. So if a Boolean expression is given to us which is not in canonical form, first we will be converting that expression into a canonical form, then replacing the variables with 0 or 1 to get the binary value, and then binary value will be replaced by the decimal number. So that those numbers are the min terms. Min term location is the locations in the truth table where we are getting the high output. Okay. So these are the min terms which are being provided to us for solving this question. So there are various steps. The first step will be to write these min terms in their binary form. So we can write 0 as 0 0 0 0, then 1 as 0 0 0 1, then 2 as 0 0 1 0, 3 0 0 1 1, 5 0 1 0 1, 7 0 1 1, 8 1 0 0, 10 1 0 1 0, 12 1 1 0 0, 13 1 1 0 1, and 15 1 1 1 1. So these are also written here as well. Okay. So next step is to write the index for each binary value or each binary term. So what is index now? Index is a number of ones present in a message. So if we check that there is no one present in that binary representation 0 0 0 0, so index is 0. So that's why the index of this term is 0. 0 0 0 1. So only one is present, so that's why index is 1. Again 0 0 1 0. Again only one is present. 0 0 1 1. 2 ones are present. 0 1 0 1. 2 ones are present. 0 1 1. 3 ones are present. 1 0 0. 1 1 is present. 1 0 1 0. 2 ones are present. 1 1 0 0. 2 ones are present. 1 1 0 1. 3 ones are present, and last 1 1 1 1. 4 ones are present. Okay. So we can calculate the index for each binary term. Then the next step is arranging these terms in increasing order of their index. So that means we will be sorting these terms. Okay. First term which will be appearing is the one having minimum index. So in this case we are having the term with 0 index. So this 0 will be appearing in the sequence as the first term, and then we will be having this one corresponds to 1, this one corresponds to 0 0 1 0, that means 2. Similarly then this one corresponds to 1 0 0. So the sequence will be 0 1 2 8 and so on. So this is how we have arranged these min terms. So 0 1, 2, 8, then these all three are having index 1, and then terms with index 2, 3, 5, 10, 12. So all these terms you can see from their binary representation, they are having index 2. Then terms with index 3, 7 and 13. 7 is 0, 1, 1, 1, 13 is 1, 1, 0, 1. 15, which is having 4 ones, 1, 1, 1, 1. So this is the first table which is being prepared by arranging the minterms and increasing order of their index. Okay. So the next step is to group these minterms. So what is the criteria for grouping these minterms? We will be grouping the minterms from one index with the next higher index only. That means minterms from first group is having only one term, which is having 0. So index 0 terms will be compared with index 1 for grouping possibilities. Index 1 term will be compared with index 2 for grouping possibilities, index 3 and 2 with 3, 3 with 4. Okay. So from one index we will be using the next higher index for checking the grouping possibilities. So we can check that 0, 1, 1, 2, 0, 1 is a possibility. So this 0, 1 we will check, 0, 2 we will check, and 0, 3 we will check. Now what is the criteria for checking that? If the two terms which are being compared are differing by only 1 bit, then we will make a group for that. Okay. So we can check that 0 is 0, 0, 0, 0 and 1 is 0, 0, 0, 1. That means 3 positions. This one, this position is same, this position is same, this position is same. Only 1 bit difference is there here. Difference in 1 bit position only. Okay. That means a group can be formed for 0 and 1. So we will write here minterm group, and first group being formed is 0 and 1. This difference is 0 minus 1, difference 1, or 1 minus 0, difference is 1. This difference we will be using in the next table. So that's why I am writing it here. For the time being, this difference has no significance in preparation of this table. Okay. So we are writing this difference so that we will be able to use that table in preparing the next stage table. Okay. So 0, 1, what is the value which will be written here is, because these 3 positions are identical, they are being repeated, and the one which is differing will be replaced by a dash. Okay. So this is how 2 terms can be grouped. The differing position will be replaced by dash and all 3 identical positions will be retained. Okay. Similarly, proceeding for 0 and 2. Okay. So 0 and 2 we can check that 0 and 2. This is differing here and rest of the 3 positions are exactly similar. So for 0 and 2 we can write that 0, 0, dash 0. Okay. Just give me a second. I have mentioned it in the difference section. Difference is 2 and 0, 0, dash 0. So this is the group formed for 0 and 2. Similarly, 0 and 3, 0 and 8, sorry. So 0 and 8, when this group will be formed, you can check that difference is 8 and pattern will be dash 0, 0. So grouping from 0 index with grouping from terms from index 0 are being grouped with the terms from group index 1. So these are the all 3 possibilities we have checked that, and all 3 possibilities have resulted in a valid grouping. Okay. Now checking index 1 term with index 2 terms. That means this 1 will be compared with 3. So checking 1 and 3. So 1 and 3, is there any possibility? Yes, we can see that 0, 0 is same, 0, 0 is same, 0, 1. This is the point of difference. Okay. and 1 1 is same. So I am writing 0 1, sorry 0, not 0, 1 3. So 1 3, difference is 2. So what will we be writing? 0 0 dash 1. Okay. And one more thing, we have to tick all the terms which are getting participated in next grouping stage. So this 0 has been used, 1 has been used, 2 has been used, 8 has been used, and this now 3 has also been used in the next stage grouping. So we have to tick all these terms, because at the end when all the tables are completed, we will find that the terms which are not getting ticked are the ones which will be generating the answer. So this tick is very much important. If we miss any of these ticks, then at the last stage when we will be getting the answer, we will be having some extra terms which might give a wrong answer to the question. Okay, so this ticking of the terms which are participating in any group is very much important. Similarly, we can check 1 and 5. Okay, 1 and 5. If we check 1 and 5, 1 is 0 0 0 1 and 5 is 0 1 0 1. So difference is 4 and the resultant will be 0 dash 0 1. Okay. So 5 is also participating, so we will take that. And similarly, we can complete the complete table. We can complete the whole question. 1 and 10. Now you can check 1 and 10. 1 and 10, if you see that 1 is 0 here and 10 is 1 here, and again these two are zeros are same, there is a 0 here and there is a 1 here. That means 1 and 10 are differing by 2 bits. So 1 and 10 cannot form a group. Okay, so we will not be taking 10 and we will not be writing 10 in the next stage table. So this 110 group is not formed. Before that, every group we checked was getting formed because they were differing by only, the terms were differing by only 1 bit. But this 1 and 10 is differing by more than 1 bit. Okay, so this 110 will not be written here. Similarly, we can check 112. So this 112 is also differing by 2 bits, because there is a 0 here, there is 1 here, there is 0 here and there is 1 here. So it is again having 2 points of difference. So again 1 and 12 will also not be formed. Again 12 will not be ticked. So this we have checked with first term from index 1 is compared with the 4 terms from index 2. Similarly, picking the next term, that means 2 from index 1 and comparing 2 with 3, 5, 10 and 12 from the next higher index. Okay. So 2, 3. So 2, 3 we can check that 2, 3 is getting formed. So 2, 3 is getting formed, then we can check that 2 and 3 0 0 1 dash 0 0 1 dash and the difference is 1. Similarly 2, 5 you can check 2, 5 it is not getting formed because it is differing in more than 1 bit. Okay. So if we need to check every single term from one index with the every single term in next higher index, then preparation of this table will take quite a bit of time. So I am giving you one shortcut for that. What is that shortcut? We will be checking only those grouping possibilities where the difference is in 2 raised to the power form, 2 raised to power n form. Okay, we can check here 0 1, difference is 1, which can be written as 2 raised to power 0. The 0 2, difference is 2, difference can be written in 2 raised to power 1. 0 8, difference is 2 raised to power 3. 1 3, difference is 2 raised to power 1. 1 5, difference is 2 raised to power 2. 2 3, difference is 1, that means 2 raised to power 0. So all these grouping possibilities which are resulting in difference of 2 raised to power n are only positions which we need to check. I am not saying that these are the ones which will definitely be forming a group, but we will be checking only these. Okay. So if any of these terms are resulting in a valid group, we will be writing in that table and ticking the term. And if it is not resulting in a valid group, that means if they are differing by more than 1 bit, we will be not ticking that group. we will not be taking that term and we will not be writing it in the next table. So proceeding in a similar way. So this 2, 5 cannot be formed because difference is 3. Similarly 2, 10, difference is 8. 2 from index 1, 10 from index 2. So 2, 10, difference is 8. So there is a possibility, we have to check, because difference is 8, that means 2 raised to power 3. So 2, 10, if we check 0, 0, 1, 0 and 10 is 1, 0, 1, 0. So dash 0, 1, 0, dash 0, 1, 0. So this is 2 and 10, difference is 8. Okay. So this has resulted in a valid grouping. So we will take 10. 2 is already taken because we are not taking that term how many times it is participating. We are not interested. If it is participating even once, we will be taking it. Okay. 210. Similarly, proceeding for 212. 212 difference is 10. So we will not check that because the difference is not in 2 raised to power n form. Then proceeding with 8-3. Again, next tip I am giving you. If the term from the previous index, when it is compared with the term from the next index term should be greater than the previous term. That means you can check here the second term in all these groups is greater than the first term. So when this 8 will be compared with 3, we need not to check that. 8 comparison with 5, we need not to check that. These will not be making a valid group. 8 and 10. 8 and 10. Now 10 is greater than 8. That means next term from the next index is greater than the term from the previous index. So this will result in a valid, this can result. Okay. This is not the guarantee that definitely it will be formed, but this can result in a valid grouping. So 210, sorry, not 210, 810, 810 difference is 2. So 810 difference is 2, we can check 1,000 and 10 is 1,010. So 10-0, 10-0. So this is 8 and 10. Okay. So similarly 812, 812 difference is 4. Okay. So 8 and 12 difference is 4. In the previous case difference was 2. 812 difference is 4 and 1,000 and 1,100. So 1-0-0. Okay. Now we can see that all the terms from index 1 are compared with all the terms from index 2. So all these grouping possibilities between index 1 and index 2 are checked, and wherever the valid groupings were formed, we have mentioned in the next stage table. Okay. Similarly, we will check the grouping possibilities between index 2 and index 3. So 3, 7 will be compared. 3, 7 difference is 4. So 2 raised to power 2. So there is a possibility that group will be formed. So we can check 0, 0, 1, 1, 0, 1, 1, 1. So 0-11, 0-11. So this is 4. 3 and 7 difference is 4. Similarly 3 and 13 difference is 10. We need not to check. 5, 7 difference is 2. 5, 7 difference is 2. So what will be the resultant? 0-1-1. 0-1-1. Then 5, 13 difference is 8. Again there is a possibility. 0-1-0-1. 1-1-0-1. So -1-0-1. 5 and 13 difference is 8. So 7 has also participated, 13 has also participated in next stage grouping. So I am taking that. So 5, 13 done. 10, 7. 7 is less than 10. So need not to check. 10, 13 difference is not in 2 raised to power n form. Need not to check. 12, 7. 7 is less than 12. Need not to check. 12, 13. We need to check because 12, 13. 13 is greater than 12. And difference is 1, which can be written is 2 raised to power n form, that is 2 raised to power 0. Difference 1 is 2 raised to power 0. So 12, 13 can make a group. So we need to check 1, 1, 0, 0 and 1, 1, 0, 1. So 1, 1, 0 dash. Okay. 1, 1, 0, 0 and 1, 1, 0, 1. So 1, 1, 0, these three 1, 1, 0 are same 1, 1, 0 and the last bit is different. So we have replaced it with dash. So 12 and 13 are also making a valid group. Difference is 1. Similarly, we can proceed with the next stage. index 3 with index 4, 7, 15, difference is 8. So 7, 15 will also be making a group 7, and we can check that 0, 111, 1, 111, dash mean, that means dash 111, difference is 8. So 7 and 15, difference is 8, 13 and 15, 13 and 15, difference is 2. So 13 and 15 will also be making group 13, 15, and this is the point of difference. So 1, 1 dash 1, 1, 1 dash 1, difference is 2. Okay. So this is the next stage table which is being prepared from this ascending order index table. Okay. So this is the first table actually which we have derived from this originally provided data, which is having only the terms, index and their binary representation. So this we can say grouping table 1, group table 1. So this was actually table, this was a initial table which was giving the data, but this is the first grouping table. Okay. Now we will be preparing the next grouping table, and this parameter will remain the same, but an important thing needs to be remembered. Wherever the grouping from 0 index and 1 index was completed, here we need to make a partition. Okay. Similarly, terms from index 1 and index 2, where it ended, here we need to make a partition. Similarly, 2 and 3 grouping completed here, we need to make a partition. Okay. So we can see that in the first table we were having 0 index term, 1 index term, 2 index term, 3 index term, 4 index term. That means the complete table was divided in 5 parts. Now we can check that the complete table is divided in 4 parts. Part 1, part 2, part 3 and part 4. Okay. So what we are trying to do is making the higher size groups wherever possible. So these single terms are now converted into pairs. Now we will check whether these pairs can merge to form a quad. That means this G1, G2, G3 and G4. Now these will be compared. Okay. This G1 group, min-term group from G1 will be compared with min-term groups from G2, and again we will be writing the group, making the group if those min-term groups are differing by 1 bit only. That same parameter which was being used to write this first stage table from the initially provided data, that whichever min-terms are being grouped, they should be differing by only 1 bit. Again, so for this next higher grouping to be possible, again this rule is valid. Okay. So let's proceed further. First of all, writing this in the fair form. So this is the complete table now. Now this table has converted into this table, all terms are getting ticked, and there are the partitions. Here is a partition 1, partition 2, partition 3. So you can write here as partition 1 terms, these are the partition 2 terms, partition 3 terms and partition 4 terms. So from first partition, now comparison will be done with second partition. So 0, 1 will be compared with 1, 3. Okay. 0, 1 is 0, 0, 0 dash, 1, 3 is 0, 0 dash 1. So this 0 is identical, this 0 is identical, 0 dash dash 1. That means these are the point of difference. So there are 2 points of difference. So that means 0, 1 and 1, 3 cannot be merged. Okay. 0, 1 and 1, 3 cannot merge. So we need not to tick that, and we need not to write it in the next stage table. Now again, is there any shortcut that I can apply here? Because comparing 0, 1 with 1, 3, then 0, 1 with 1, 5, 0, 1, 2, 3, 0, 1, 2, 10. So there will be so many comparisons. So is there any shortcut that I can check a few of them and I can make the next stage table? Yes, there is a shortcut. What is that shortcut? Wherever the difference is identical. So from partition 1, this 0, 1 is having difference 1. I need to check that with only that group in partition 2 which is giving the same difference. So 0, 1 and 2, 3. Okay, 0, 1 and 2, 3. So 0, 1, 2, 3, same point, same difference. So they can make a group. I'm not saying that these will definitely make a group, but we need to check only those terms, those groups from partitions with next partition where the difference is identical. So 1, 1. So 0, 1, 2, 3, we can check 0, 0, 0 is there, 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 1 is there. That means 1 point of difference is there, and last one is dash, dash. So this becomes 0, 0, dash, dash, and group is 0, 1, 2 and 3. So the 0, 1 has participated, 2, 3 has participated. So ticking that term. Okay. Similarly, there is no other term in partition 2 which is having the difference 1. So 0, 1 is compared with 2, 3 only and written here. Okay. So proceeding further, 0, 2 difference is 2. So is there any term with same difference? Yes, there is difference 2 is here. 0, 2, 1, 3. 0, 2, 1, 3. Now 0, 2, 1, 3, that means the group members are identical. 0, 1, 2, 3. The new group which is getting formed is 0, 2, 1, 3. Earlier group was 0, 1, 2, 3. So they are forming a group. So I am taking them, but I am not writing it in the next stage table because it is already present there. You can check that 0, 2, 0, 0, dash 0, 0, 0, dash 0, and here difference to 1, 3, 2, 0, 0, dash 1, 0, 0, dash 1. So this new group which is getting formed with difference 2, 0, 2, 1, 3, again we can check that it is 0, 0, dash is common and this is a point of difference. So 0, 0, dash, dash. So if I write it, it will be replicated. Okay. So either I write 0, 1, 2, 3 or 0, 2, 1, 3. Both are same. So I am not repeating that. Okay. So, but I am taking that. Important thing is that I am taking that because it is making group, but I am not writing in that group because it is already there. So 0, 2, 1, 3. Similarly, we can check with 0, 2 differences here 2 and 8, 10. 0, 2, 8, 10. These two terms, if I compare that 0, 0, dash 0 and 1, 0, dash 0. So dash 0, dash 0, dash 0, dash 0, 0, 2, 8 and 10. So 0, 2 is already take, I will take 8, 10. Okay. Now there is no more 2's. So 0, 8, 0, 8 comparing it with 2, 10. Why? Because difference is identical. 0, 8, 2, 10. Now you can again check 0, 8, 2, 10. 0, 2, 8, 10 is already written there and 0, 8, 2 and 0, 8, 2, 10 is a new group. It is a new group because it is valid, it is satisfying the grouping criteria, but it is already there in form of 0, 2, 8, 10. So I will tick that 0, 8 and 2, 10, but I will not write it because it will be repeated. Okay. So in this way we have compared the terms from partition with the terms from partition 2. Similarly, I can compare the terms from partition 2 with partition 3 and similarly partition 3 with partition 4. So if I do that, so we can check that 1, 3 difference is there, 5, 7. So 1, 3, 5, 7 can make a group. We need to check. 1, 3 is 0, 0, dash 1 and 3, 7. 1, 3, 5, 7, 0, 1, dash 1. So 0, dash, dash 1. So 0, dash, dash 1. This is 1, 3 and 5, 7. So we are already 1, 3 is ticked and 5, 7 I am taking. Okay. So 2, there is no more 2. So that's the only possibility. 1, 5 difference is 4, 1, 5, 3, 7. But we can check that 1, 5, 3, 7, this 1, 5 and 3, 7. It is already present in form of 1, 3, 5, 7. So I have ticked it because it is forming a group, but I am not writing it. Then proceeding further, 2, 3 and 12, 13. 2, 3, 12, 13. You can check there. 2, 3 is 0, 0, 1 dash and 12, 13 is 1, 1, 0 dash. Okay. So we can see that there are more than 1 point of difference. So this 2, 3 and 12, 13 are not making group, although the difference is same, but they are not forming a group. So that's why I was saying that we need to check only those terms, but checking does not mean it will definitely form a group. Okay. So similarly, completing the complete table, we will get this. So this is the first stage table, this is the second stage table. In that we can see that there were few terms, this one which has not participated in the next stage. Similarly, this 12, 13 has not participated in the next stage, and this is the next stage table. This is obtained by partition 1, partition 2. This is obtained from partition 2, partition 3, and this is from partition 3, partition 4. And we need to check that, we need to continue that till the last stage grouping has also completed. That means we need to compare this 0, 1, 2, 3, 0, 2, 8, 10 from partition this P1, P2 group to P2, P3 group. So P1, P2 need to be compared with P2, P3. So why we are doing that? So that we can check that these quads are making octets or not. So these group of 4 can be converted into 8 or not. So that's why. But we can see that 0, 1, 2, 3. If I see this 0, 1, 2, 3 and compare it with 1, 3, 5, 7, I can see that no more further grouping is possible between P1, P2, P2, P3, and similarly P2, P3, P3, P4. So no more grouping is possible. That means these are the terms which cannot be further grouped now. So these are not getting ticked. So this stage, so this RSTU, these are unticked terms. So we have mentioned names for these unticked terms. So the terms which are not getting ticked have been provided with the names. So PQ from this table. Similarly, if in any other question there could have been a possibility that in the initial phase only there could have been a term which may not have participated in the next stage table. So this table, initial first table which we had prepared from the question provided data, there could be an unticked term in that table as well. So we have to check all the tables where we are finding any unticked term. So that unticked term will be used as the prime implicant. So this PQ from this side, and these 4 terms are not participating further. So these are being named as R, S, T and U. And what are these PQ, R, S, T, U? We can check that this P is 8, 12 and binary representation is 1-00. 1-00 means A is there, B has been eliminated because there is a dash there, and C is 0, D is 0. So A, B has gone, C bar, D bar. So P is A, C bar, D bar. Similarly, this Q is 110 dash. So A, B, C bar and D is gone. So A, B, C bar. Similarly, R is here. R is 0, 1, 2, 3, 0, 0 dash that. That means A bar, B bar, C and D are gone. So R is A bar, B bar. Similarly, S is B bar, D bar, T is A bar, D, and U is BD. U is, you can check, this is corresponding to B, this is corresponding to D. So this is how we have written the min terms. We have grouped the min terms. So these are the various tabulation stages of grouping. So one more last table is now pending. So all these unticked terms, are called prime implicants. Prime implicants are identical to the term identical to the K-map groups. So any group which can be formed in a K-map is a prime implicant. Now out of those groups we need to check that which group is required, which group is not required. So again that is same in this tabulation method as well. So we have seen that there are 6 grouping possibilities, 6 groups are there. Out of these 6 groups which are essential for me to write the answer. So for that we will be preparing that prime implicant table. Now this table is completely different from all these tables which have been prepared so far. So all these are grouping tables. Now we are making a prime implicant table. So these are the prime implicants P, Q, R, S, T, U. So here we have written P, Q, R, S, T, U on this side, and these are the terms which are being provided to me in the question. These are the min terms. So it is not having 0, 1, 2, 3 all the terms. These are the terms which are provided to me in the question. You can check from there. 0, 1, 2, 3, 5, 7, 8, 10, 12, 13, 15. So 0, 1, 2, 3, 5, 7, 8, 10, 12, 13, 15. So I need to fill that entries now. P is having 8 and 12. P is having 8 and 12. Similarly, Q is having 12, 13. Q is having 12 and 13. R is having 0, 1, 2, 3. 0, 1, 2, 3. S is having 0, 2, 8, 10. 0, 2, 8 and 10. Then T is having 1, 3, 5, 7. T is 1, 3, 5, 7. Then U is 5, 7, 13, 15. U is 5, 7, 13 and 15. Okay. So after entering these crosses in this prime implicant table, we need to check for the columns. We need to check every column, and I need to identify which are the columns where there is a single cross. Okay. So I check column 0, there are 2 cross. Column 1, 2 cross are there. Column 2, 2 cross are there. Column 3, 2 cross are there. Column 5, column 7, column 8, column 10. This column 10 is having only a single cross. Okay. So I circle this cross. Column 12, again 2 cross. Column 13, again 2 cross. Column 15, 1 cross. Circling it. Okay. So I am circling all those crosses which are unique in their column. That means there is a single cross in a column. I am circling that cross. Now I will be checking the rows, and wherever I find a circled cross, I will use that prime implicant. That prime implicant will definitely be part of my answer. So in first row there is a no circle cross, second row there is no circle cross, third row there is no circle cross, and in the fourth row we can see that there is a circle cross here. So that means this S will definitely be part of my answer. Similarly, this cross is there in the last row, which says that U will also be definitely part of my answer. So final solution will definitely be having S plus U. Okay. S and U can be replaced with these B bar, D bar. So this B bar, D bar plus U is BD. So these two prime implicants will definitely be part of my answer, but I am not sure that these are the only terms. So P, Q, R and T will not be part of my answer. I cannot say that. I need to check. Why? Because all these groups should cover all the minterms which were provided to us. So I can check that this S is having 0 to 8, 10. So this 0 to 8 and 10, these are covered by S. Similarly, this through U is covering 5, 7, 13, 15. So 5, 7, 13 and 15. These 4 terms are covered by U. So I can still see that this one is left, 3 is left and 12 is left. 1, 3, 12. So this 1 is left and this 3 is left and this 12 is left. So I have to cover these 1, 3 and 12 also. And 1, 3 and 12 can be grouped from the remaining prime implicants. Remaining prime implicants are P, Q, R and T. So my first attempt will be to cover all these 3 using a single prime implicant. It will be the best position, because like in K-map, we use minimum groups to cover all the ones. So these are all the ones only. 0, 1, 2, 3, 5, 7. These are the minterms. Minterms means the locations with high output. High output means 1. So these 0, 1, 2, 3, 5, 7, 8, 10, 12, 13, 15 are actually the ones of the K-map. Okay. So we need to cover all the ones. So 1, 3 and 12 are left. So I am trying that these 1, 3 and 12 can fit into a single group. So 1, 3 and 12. I can see that there is no group. 1 is there in T, 3 is there in T, but 12 is not there. So 1, 3, 12 cannot be. I can see that there is not a single group which is covering all these 3 terms. So I can check that 1 and 3 are getting covered by T. Similarly, 1 and 3 are also getting covered by R. So I have an option now, T or R. I can pick any one to cover 1 and 3. T and R to cover 1 and 3. Okay. Anyone from T or R can serve the purpose. Similarly, now we can check that 12 is also left. I can see that 12 is present here. So any term from P or Q can cover 12. So P or Q to cover the term 12. So if I do this, all my terms will be covered. So I can see that essential PIs are the one which are definitely going to be part of my answer. So I've seen that these S and U were the essential prime implicants, S and U. Additional prime implicants, I can see that T or R, and between P and Q, P or Q. Any of these combinations will be resulting in a valid answer. So let's say I'm choosing one of them to write the complete answer. Okay. So I am deleting it and choosing T from this side. Sorry. So T from this side, P from this side. So S plus U plus T plus P will be my answer. And writing T is 1357, that means A bar D plus P is 812, corresponding A C bar D bar, A C bar D bar. So this is my final answer using this tabulation method. Okay. So this is the minimization of a Boolean expression using tabulation method. So we have been now checking some particular cases. Particular cases can be, there could be a question in which these prime implicants which were essential are the only ones which are required. That means there could have been a possibility that S and U, which are the essential prime implicants here, cover all the possible terms. Okay. So in that case, there would be no requirement of additional prime implicants. Okay. And there can be a question where would be no prime implicant, no essential prime implicant. There could be a case where there is no essential prime implicant and all these additional prime implicants we have to identify on our own, that which possible grouping pattern, which if I pick these additional prime implicants, minimum additional prime implicants to cover all the possible min terms. Okay. So in this way we can write the answer either in form of essential prime implicants only or additional prime implicants only, or in this case which we have shown, combination of essential and additional prime implicants. So this is the tabulation method for this given question. And one more thing, there can be don't care terms as well. There can be don't care terms as well. So the only difference is that if, let's see here. So let's say if these 12, 13 and 15 were don't care. Okay. If these three terms were don't care, then step 1 will be same, step 2 will be same, step 3 will be same, table 1 same, table 2 same, table 3 same. That means in the grouping stage, there is no difference if that given term is a min term or a don't care term. That means even if we were provided with a question which is having don't care terms, in that case, this don't care, presence of don't care would not have affected my grouping possibilities. The only thing where the difference lies is while preparing this prime implicant chart, because don't care term, if we are able to connect with K-map, we can recollect that don't cares were used to make groups, but it was not mandatory to cover those don't care. Okay. So if it is not mandatory to cover these don't care, then like in that case 12, 13 and 15, these three were the don't care term. So I can delete these terms from this table. So the prime implicant chart, so this PI chart which we have prepared in this form will be covering 0, 1, 2, 3, 5, 7, 8 and 10 only, and 12, 13, 15. These don't care columns will be removed from that. Okay. So there could be possibility that don't care terms is lying in the middle of this table. So that particular term which is a don't care term, whether it is lying in the initial part of the prime implicant chart, last part of the prime implicant, middle, random, wherever. So the don't care term will not participate in the prime implicant chart. That is the only point of difference between a question which is having don't care or not having don't care. So with this we come to the end of this lecture, in which we have minimized a given Boolean expression using tabulation method. So we just need to remember that like K-map, we need minterms to solve Boolean, to solve the expression using tabulation method. So with this we come to the end. Thank you very much.